In this lecture, we're going to dive into timber decking design. We'll go through the analysis to calculate the maximum shear and flexural stresses for the distributed and point load cases, then compare this to our capacities. Like I mentioned before, we'll go through the topics using the W3 or W3E standard details as an example because these are the most commonly used details in our program countries. The following checks will come from the NDS for wood construction. And our general values for flexural capacity, capital FB, and shear capacity, capital FV, will come from the EIA Bridge Binder Volume 2, Section 3.3 for material properties. But if we have the exact species of the timber, we can use the NDS supplement for determining these capacity values. We'll take our capital FB as 3.96 megapascals and our capital FV as 1.44 megapascals. Now, Chapter 3 from the NDS gives us equations for flexural stress in bending members and shear stress in bending members. And do note that the M term here is going to be our moment from the distributed load or our moment from the point load, and our V is going to be our shear from the distributed load or shear from the point load. And we're checking this as an or, not as a combined loading. For section properties, breadth and depth values can be looked up in the NDS supplement as well as second moment of inertia and section modulus, but we'll calculate this on our own because the lumber is a slightly different size using centimeters versus inches, and we can sharpen the pencil on our calculation. So as you may remember, we have our term for second moment of inertia and section modulus here based on the section properties. And do note that because this is a deck board, it's going to be used in the weak axis direction. The last set of values to find is our adjusted capacities, FB prime and FV prime. These equations come from section 4.3, Adjustment of Reference Design Values, table 4.3.1. Be careful because not only do different factors apply between shear and bending, but sometimes the factor is different if it is for shear or for bending.